Okay, let's get back to it. When Twitch catches up, of course. There we go. Seems live. Just waiting. There we go. Perfect. Okay, welcome back, everyone. So, today, before the break, we rewrote the entirety of the analysis, but we're splitting it into phases. We're doing a resolving phase that purely is concerned with like that path, where does it go, and now a second checking phase in which the output will be a lot more informed than when we had it in the first place, which is now going to be called a validation phase, where before the analysis is being split into. Now, I want to also try to do something a bit more complicated than what we used to do. If I go look at, it's no longer result is checked now. I'd like to be able to do something like this, where I store type information as, you know, more, no longer just like this points to here with those parameters, but completely inline. The problem is this could be a cyclic graph, because a struct type of A could be containing an array of B, and then B could be containing an array of A. It is perfectly valid for cycles to appear here, which means we are gonna need a way to allow this, while not just having names that point to something else, but actually having, like, this will be a pointer back to the same thing, basically. So that is gonna be a bit tricky. And I am not entirely sure how I'm going to do that. We're gonna have to figure it out. Especially since I'm gonna need also that to contain, replace, like inlining the type parameters and so on. This is gonna be somewhat tricky. So I think what I'm gonna end up doing is creating those types on the fly for the type expressions, but still in the scope have some kind of indirection for some of the things. Like this name with this thing points to that, basically. Like this name and those arguments, those type arguments, I think will be what will be used as a key. That being said, yeah, I'm not entirely sure how we're gonna do that. This is gonna be complicated. But anyway, I think the thing we want to do is the same thing we've done in the past. So I'm basically going to take the core thing that we had before and make that the base for what is currently the second phase of the analysis. The only thing is we are probably not going to need, I'm going to need to check. I don't want a full definition for everything, because I think rather than keeping a cache of definitions, I will probably want to keep a cache of like constants, functions, and types, rather than keeping a amorphous definition kind of thing, because like that way I can separate type and values, and it's probably a lot more helpful. I'm almost even tempted to go back to the this thing here and split top level declaration even further, to not have that, but instead have something that like function name, struct name, and so on. Because that way I don't have to do. Yeah, I'm tempted to do that. But I might not be able to do that. It depends on what. When I do other modules, when I import things into scope, I would need to know the other modules what they export, basically. If I just have their names, then that's just a top level definition. But no, by definition, I will need to know what they export, because I will need to do those lookups as well. Okay, so yeah, I can probably break this down into, that's a top level, just struct. Yeah, struct enum constant function and type alias. I don't think we did any of this as part of the resolution. This will be done by whatever associates a role with this to create the top level scope. So this doesn't change anything. There we go. So that type information will be used for annotation in functions. That is not the type information that I will want to have when I am doing. That's probably the key to it. That's probably the key to it. So what I will want will be to have a type declaration at the top level that will either be a type alias, which points yeah, I will want to have the indirection. So it will point to another name and we'll have a hash map of identifier to that can't be a name. That's complicated. I guess it has to be a type declaration there as well. Because that's the thing I want to use. That's my output, basically. That is type annotation for expressions. And this is the context I'm carrying with me as part of like, okay, I'm done resolving this thing. So would that be type info? I don't like the name info, it's too generic. The problem with type info is that it doesn't tell me maybe actually it's fine to not. I need to think for a tiny bit. Is it fine to not resolve the declaration of the and to only resolve them when I need to know a type? Basically, when I need to create one of this, I go look up all the information I need until I'm able to do that, basically. The problem is that this could be infinitely recursive. I don't have a good way to prevent that unless I add indirections into this. So I think I need indirection, which I had before. That's unavoidable. So I think any type will need to have that level of indirection. And the name. And I'm back. Basically, the problem is I'm back with the path info that contains the type parameters and everything, but I lose everything that makes this interesting. Which is why I don't want to do that. Then I suppose type path is a possible thing. And the type path will contain a unique name that points to. Wait, name doesn't contain. Name contains the parameters. That's fine then. So a type, then the but that means I'm back at the same problem where I add this level of indirection where a struct type has a name and it could be something that is not a type. I think I don't have a choice for now. So I think for now we're gonna do that. So that means that for now. Validate a type alias. What will that be? Because I need to record the how do I record type information at the top level for the use of the resolution later on? This is tricky. This is very tricky. Do I just use the common stuff I had? After all this worked in the past, I used that as the resolution and I just translate that to something else when it's time to do annotations of my... Yeah, that might not be the worst idea. That might not be the worst idea. Every time I have to do a lookup, oh, this is trickier than I thought. Basically, what I want to avoid as much as possible is to have to keep a bunch of indirections and lookups in the output of this phase. I've introduced, this is the old output of the phase, and I've introduced a bunch of new things here to try to make it so everything now is a lot more structured and I don't have to do lookups afterwards because I have the full information of everything. Because I will need type information to do type checking. But type checking could be done purely with some names. Because a fully resolved type in which there's no longer any placeholder or anything, that is, I can compare for equality there. Huh. I still think I want to try to do the cycle thing. I think that would be better. But that just means I need to keep track of type alias. Type aliases are really the pain here. Because I don't want them reflected in this. So maybe what I need is I need to keep them separate at the top level. I need to keep in my context, which means when I resolve a type, I try to look for it in the type aliases, and if it's not there, then I just go look for it in the actual types. Or do I add another layer of indirection where maybe I do that? Because that's a resolved type information, and that would be so like another a type tree, and there would be at the core a base type. It's just a type. And I think I don't have the, yeah, I will move a few things. Okay, so an enum is going to be just a list of identifiers. I don't need anything else, I think. I guess I could, however, do more things. An enum, I could store enum length, which is an int, which avoids having to recompute it a bunch of times. Actually, an enum must be a non-empty, come to think of it. So I believe in common it is as well. No, it's not. It should be. Actually, what does my parser allow? Does my parser allow empty enums? I don't think it should. Ah, no, we allow an empty enum. I guess that's fine. Just means there's no possible value of that type, which means it's always impossible to create. For an enum, maybe it's just enough to just do a list. It's fine. That's what it was, is a list of identifier, yeah. Oh, actually, we should probably do, since name resolving is done as part of the resolution phase, I should probably do a resolve enum here. Enum info. We're gonna do here. I'm gonna do the same thing I've done for the others here, which is gonna be find duplicates and report enum duplicates, which is basically what we were doing before in core. For the analysis of an enum. Oh, we were not doing that here. Oh, yes, of course it makes sense since we're doing the creation of the top level scope at the root level, which means we have to put the constant values in scope, which is where we check them. Yeah, okay. I would probably want to make some of those functions here available. Yeah, I might do that later. However, that means I can remove what I've just done, which is always good. And so we have a base type, which is this. Oh, type chain. And or we have hello again. Or we have a type alias, which points to a specific type. And now I will need. So that's the resolved thing, and I will need. Because I will need to know parameter substitution. I will need to know that foo is a struct with two type parameters, and I will need to know the type mapping as well. So I think I will need to keep a thing that has the layers of indirection there. For instance, if I have a type alias, can it be pointing using a name that contains parameter information to just another type? But the problem is name is it's not specific to a type. That's the whole thing I'm trying to avoid. I'm trying to avoid having things where the representation can point to something that's incorrect. But I think the problem is if I don't create this indirection, then that's a cyclic graph of types. And also this information does not allow me to, well, except if I have name here, does not allow me No, I think I will want to find a way to have this with type here. No, I don't. Because the IR, it's fine for it to be a name. Okay, so this has to be a name. That's fine. It's fine. I can trust that it's a type because I have already checked that at that point. But I will still therefore need a struct information. I will still need to know the parameters so that I can do proper substitution. And I will not need to know the field, which will be that non-empty list identifier and something that points to like name, so unique name and type parameters that points to another type. Yeah, I think I have no choice but to keep that that indirection. I can't fully inline because then I have to break the cycles and it becomes a nightmare. So I think for now I'm gonna keep this. So struct type will continue having a struct info. Let's be consistent with the rest of the code. Even though this is no longer the same struct info, let's keep, is it called params? It was called params. Let's try to keep some consistency in the naming. Function type. I think I don't need the detail like, no, because I need the parameters. Okay. So let's do the same thing. Function info. Wait, no, that's for a type. Yes, this creates a type that is basically a record that has those two fields. You can create a type of like different variants or create a type with like different fields. This is basically the equivalent of saying like struct info has two. This constructor struct info has two fields. One is a list of identifiers, and the other is this non-empty list. But I just give names to the fields so that I can then access them afterwards, and I can also create lenses to have access to them. Do I need to keep the? No, I think the function type. The function type is something that's only gonna exist for function pointers, and that only makes sense in a context where it is fully resolved, and therefore being fully resolved, it doesn't need the identifiers until I add syntax in the language for function types, in which case, no, I will need that. Well, not even no, there will always be, there will never be a type parameter on a function type, even if I add it for variables or anything like this. So no, I think function, it's still good to have it like this. I'm gonna do it like this. It's gonna be the function argument, the function arguments, args, which are gonna be that, and the fun return, which is gonna be a maybe type. And in this case, I suppose name, because we keep this layer of indirection. Okay? And the idea of the type chain is that this allows me the notion of type aliases without encumbering my other information. And a type alias points to a name. I don't want type aliases to be in there. I want to be able to do the full substitution at any point. But to do that, yeah, basically, I need to be able to look up a type in a hash map. Like, does that type exist? Yes, it is a base type, it is this. Or yes, but it is a type alias. Substitute by doing a further lookup with that name and replacing. But I need to also know the. Yeah, that's not enough. That's not enough. Do I really need this type chain? Could I just... I think I want it, just because that way it allows me to put everything together. But I think I'm gonna just do a type alias info. Type alias info, which will contain the name it points to and the parameters that it accepts, and I guess I don't need to do the mapping. The mapping will be part of the name. Even if I have to still do a bunch of checks in the IR, this version will still be a lot better than it was before. So that should be fine. Now, this means I can do the thing I was doing before, where I do the analysis of a given thing at the top level, and it will call recursively for all of the others. Scope is no longer a problem. Okay, okay. I'm dreading a bit having to rewrite all of the analysis, but because it's not a small piece of code. But this, for instance, I can start with this, will be made a lot smaller after we are done this evening. This will not be give me a definition resolved. This will give me something. That we haven't decided yet. And I suppose this will have to do something different based on the Okay, so my logic is I will want to have at the top level a type chain like this for every type, so that whenever I do a type lookup of a type, I get that information. However, I might not always have that because there might be cycles. Type A depends on type B depends on type A. That is fine. That means, however, as part of my analysis, something that resolves a type needs to be able to say, oh, I don't have that one yet. Let's do the analysis of that type. The output of my resolution phase is a definition as well. So that means I need to be able to say, oh, that name points to that, therefore I need to be able to, yeah. So I need to be able to say, I need to analyze that definition. So I will need to do something along those lines. However, there will not be one output per thing. It's not going to give me a definition. What we'll do with it will depend on what we're doing an analysis with. And I guess I will want to do an analyze type that takes one of the definition and checks that it is a type indeed, and that could return one of those type chain thing. So how much of that do I still need? That name checking isn't at that point. That's surprising to me. I thought I was already doing that. Oh, here I'm checking another reserved. But I will probably want to do all the name checking at the top level, like all of the exported stuff from this are not... Yeah, no, I don't think it belongs here. It doesn't belong here. Root name in this context. Okay. That's the location in the cache. Okay. That's a detection for cyclic definitions. That makes sense. That's only important for types. The scope I don't need anymore. The scope was only required for name checking, which is done by that point. So all of that stuff is no longer required, which is good. It's going to make a lot of things easier. So I think, yeah, I can't have a top level analyze definition. I will need to have something a bit more specific. Like I am looking for a type. Or what else could I have? We'll figure it out. For now, let's do this as an analyze type. None of this is required anymore. This will be done elsewhere. This, however, is important. This will remain. This is, have I already done the analysis of this to break cycles? The scope I don't require anymore. With context is not something I require anymore. I'll probably be able to just do something like context. The location is the def location or something. This should probably be fine. And otherwise, do that. And if I get either a constant or a function, I can report an error. Because that's, I was expecting a type and that's not a type. Not a type. Perfect. What is not a type? That's currently in old because I've moved a few things. Not a type, and that's a role. Okay. And this, in this context, I don't have the role, but the role would be a top level declaration. I probably can probably take the name as an argument. And that's a... I've changed my role, so my role will be... That's in resolved. And this will be a constant name. That's the problem with like breaking everything. This stream is not incremental progress. This is we are rebuilding everything from scratch. Okay. Now, I have eliminated those two. Yeah, no, exactly. It is important. I think it will. The code will be much better and much more readable when all of that is done. But until it's done, and it might take a week, everything is gonna be unreadable and broken. So, otherwise, in the meantime, if it's a type alias, if it's a struct definition, if it's an enum definition, what do we do? I guess it depends. I suppose I'm gonna say analyze type alias here. And I don't need to recreate something because I am not. I don't care about generating a list of results at the end. So actually I can do that again. So this becomes that, basically. And so analyze type alias will become something that takes the underlying monad, which will have some kind of capabilities. The current name of the thing, unless the name is set in the context. Maybe I'll set the name in the context. Like every analysis will just run with in its own context. Like maybe here I'll do some kind of like with context or something that just runs its own thing. And that will probably be just the name. I don't need much else. And probably the location or something like this. I'm assuming that all of those give me a type chain, so name is no longer required. It's going to be part of the context, whatever that ends up being. And this will therefore take a type alias info resolved, and this will be an input type alias info resolved, and the output will be analyze m of some type chain. Unless I put that into... No, probably not. Okay. So what do we do here for this? Is there anything important to do? Type parameters have already been resolved as part of the previous phase. So I guess the only thing I have to do here is resolve the type of the different things within, which are all gonna be path info and things. So it's gonna be find the type to obtain the resulting thing. Okay. Because now what I have is type alias info. I have that. I have the parameters and the path info, which are a bunch of type names in that context. So for each of them, I will need to do I'll need to find a mapping to a type instead. So it's just going to be the name. Is there anything I have to do here? Because I already have the name. It's that basically. The thing I'll need to be very careful here is I want to deduplicate the way type parameters are handled, which means name lookups are gonna be tricky. Ah, okay. Oops, didn't mean to do that. I meant to do that, to have here that. Wait, I'm missing something. Am I not missing the No, the type arguments will be part of that. So I guess the raw type alias analysis, there's nothing to do. It's absolutely nothing to do. My result is purely to do a type chain, which is a type alias, in which I have a type alias info that contains the alias parameters unchanged. And okay, this is where I will translate. Ah, this is tricky. This is extremely tricky. Because this thing, path info, contains two sets of type parameters. That contains a name, which uniquely identifies something, and the type parameters given to it. In the past, I have decided that struct and other types did not have the type arguments as part of the uniquely identifying type. However, if I want to end up being able to cache something such as what is a foo of int, for instance, so that future lookups don't have to go find the generic definition of foo and do a substitution there, then I will need to stop using those two things and have a name that may contain parameters but actually doesn't. Or maybe I should not take into account the parameters of the name. They are basically an implementation detail of the mangling that happens for functions. So if I don't, then if I don't, that's a unique name that points to a struct definition regardless of, and I need to always be able to do that. But however, I need to perform some kind of substitution, and that will be the mapping, which will be for each identifier of the target type. But there again, what is... Okay. No, I need to rethink all of this. I need to rethink absolutely all of this, and I'm a bit stuck, I have to admit. The problem is the old version was ugly as hell but worked. And now, by trying to fix all of the issues in it at the same time, I have something that will be a lot better when it works, but so far absolutely doesn't. Okay, so let me think a tiny bit more about what I'm trying to accomplish before I... No, Haskell, the type system is well, oh, sorry, you mean the compiler. It depends on what you're trying to do. The fact that I'm trying very ambitious of like immediately having generic functions and like type substitution, type aliases, and all of that is where I really get, I really add a lot of complexity. But yeah, parsers are a lot easier, I think, than resolving type system and doing that kind of stuff. The thing is, I think I need... Effect systems are fun. I think the thing is, I want... What do I want all of this? What's the point of having type information everywhere? That means I can create registers in my... I mean, fun and difficult are not mutually exclusive. So I think, okay, let's reason by how what I want to achieve. I want to achieve something that is of that nature. I have a typed thing that decorates my expression with type information. That is non-negotiable. That's the thing at which I want to arrive. And I want to decorate some other things with more specific information. For instance, a field access that does deconstruct a struct. I want to bundle the struct info with it, I think. Because if I don't, then any further work on this will require me to be able to do a lookup on the name of the thing to get the list of the types. And that's something I'd like to avoid. I'd like to be able to then look at the AST of a function that contains expressions and being like, I don't need to do more lookups. I already have all the information I need. It is right there. That's the thing I want to arrive at. And this struct info will be basically just this thing of, and in this case, that's just the fields I care about. I will want them to be resolved, which means I will want them to be actual types in this case. Which means maybe this type here will not be the same as the one that appears here. Okay, now this type here is what the type I've been using in my things here. I think it's fine for it to point to a name. The IR will, after all, maybe I want to use the name thing and I want to instantiate my types in the same way that I instantiate my functions. As in, if I have a foo of t in my code, if I have something like this, and at some point in my code I talk about a foo of int, then I will want that to be a distinct type from foo of t, which is a separate thing I have in my lookup cache when resolving, but then in the output I am pointing specifically to that thing, which is different. And the idea being that then in my output, foo of int is a type that I can mangle in a particular way when I export to the LLVM IR or something, whose fields are all concrete, that do not contain any type parameter anymore. All the things have been resolved. If that's the case, then I would like that to have something that contains a type there that then is therefore that has a cycle. I want the cycle, I think. Unless, again, I'm using name because it's fine to... I also have a thing. I need to check my lowering IR thing. What does my IR type look like? Yeah, I have the problem. I haven't tried to lower structs that are mutually recursive, but I already have that exact problem. If I have structs that are mutually recursive, the only way structs can be mutually recursive without an infinite recursion is with arrays, but even then, my representation would be the same. It would be something like this. I would just have, at some point, array type there as well. And I use this type for registers to know what's in them, because I will need to be able to compute the size of something, and it needs to be So I will have cycle problems with that as well. So if this is my annotation type, this is my annotation type at the end. This is the fully resolved type. This is the concrete type. Then since I'm going to have the cycle problem anyway, I think I want that version to contain the cycle. And so here, this is purely that version where I don't need the struct info anymore. That is the type of my... Let's again reason with like what I want to achieve, and then we'll figure it out. So this is going to be the same here. This is going to contain... I can keep the function info for now, I think. But this will be a type. This is a type. So what I want is I want to be able to say this unique name points to this specific type thing, which may contain cycles. And that is fine. So I will need to do some pointer juggling, which is going to be funny. Okay? Okay. That means that I need to also keep a cache of how do I... Okay, I have found foo of int. How do I figure out... what do I store for foo so that I can create foo of int based on this? And maybe the answer is I don't, and I go re-look at foo for each. I do the same thing I do for functions, which is every time I find a type with its with type arguments, I go translate it, and every translation has to do the checks and resolve the cycles. Okay, that will probably work. Now, that means my key is name. The name is mangled for types as well. Therefore, my resolving thing will contain a cache of for a name, something like that. Let me just check then that in the core, when I'm doing analysis, the only thing I'm doing is it's just figuring out okay. So I think that works. I think I don't have invalidation to do anything for a type like this. It is just going to be a matter of I need a type, I have a name. How do I do this? Okay. Okay. So, as part of the validation, I will have some kind of validation monad, which will be the same as the one in the previous analysis, but simpler, a lot simpler. Because I will not need all of that stuff. Because I'm gonna assume I will have some kind of monad diagnosis underneath. So I'll have access to my local definitions. My foreign definitions will be their types will have to be they can't necessarily be self, because if I point to a struct that exists, so I think I'll need to keep the definition cache the same way I have. Symbols I probably will not need. That's an older thing that might not no longer be required. Yeah, that's a function info resolved. I don't need that, I think. Foreign functions, that I will need. No, I will not need. And scope, I don't need anymore. Okay, so that's a lot simpler. Definitions, local definitions, and remote definitions. And if that's the same thing, definition cache is that in both cases. Those are both definition caches. Well, I guess I don't even need to do that. I can put them all into one. And that's the definitions I have in scope, whether I have imported them or whether they are coming from other modules. So I am able to look up a name and be like, what was the definition associated with that? Okay, I'm gonna go back to name. I'm gonna make a small function, which is unmangle. Which given the name gives me another name, which is gonna be an implementation detail of some sort. Which is gonna be it's just going to be setting the name parameters to empty list. So I will need that for some lookups. Okay. So this validation monad will be a reader of, what did I go for the resolve? It's no longer called that. It's called resolution. Resolve info, resolve context. So validate info and validate contexts. I'm actually just gonna copy that. Do that. That's validate info. That's validate state. Now, I will probably not need these definitions. That's probably not correct. This Boolean stuff will become part of the diagnosis monad. That's no longer required here. Context might be still a list like this. I might keep that. Okay. Instances I will probably need to keep. That's probably going to be a thing I'm going to have to keep, because that I still need to register which functions need to be instantiated. But I can probably do that with just a name. The problem of doing that with just a name, no, I will need to figure out. I will need more information than that. So the thing I'm doing here is I'm doing something that is inspired by C++, which is to say it's ugly, which is the way I deal with generic functions is basically I do the name checking ahead of time. Like your generic function depends on, like, is for some type T does something. I do the name checking, like, hey, you say variable X, it doesn't exist in the scope, I can't do that, but I do zero type checking ahead of time. And when another module makes use of the function and instantiates it, and therefore calls that foo thing with int, then I do the actual compilation of the function, of a copy of the function. I create a new function foo of int, basically, that is based on that generic foo that existed, and I compile it then. But as a result, what I do is I keep a set of things I will need to instantiate later, which is what this set is. And I guess this is this function here that points to a definition, but with those parameters. So that's probably going to be instead. This is going to be different then. Can I, in the common thing function info, I have the identifier. I am tempted to not store the name there, but just the No, I need the full name. I need the full name. Okay, so I think name is unfortunately correct. No, that is purely the way I choose to do this, because this made-up language I'm compiling doesn't have traits. So generic functions can't be type checked ahead of time. I can't just like say, oh, it will work for any type t that happens to have this trait, basically, which allows me to do all the type checking in advance. So what I do instead is, well, I don't do type checking. You told me this is a function that works on any t regardless of whatever it is. So I don't do any type checking. And when it is instantiated, then I do a substitution. All the t become int, all the u become string, whatever, and then I do the type checking. Which is again like that's the way C++ does it. And as a result, I generate a function per instantiation of the function. So it's like if you have a foo that is parameterized by a type t, then it's like I will create a new copy of foo per like type by set of types you give to it. The only thing is, as a result, this is no longer going to be a path info resolve. It's going to have to be a type. That I will be able to then create. I will be able to. Oh, actually, can I name? Oh, that's actually an issue. If I do this, I can't recompose the name from a type, but for the mangling, I will need the name. Does that mean that at that point I store a name here, or do I store the type already? Because if I store the type, nah, I think I'll store name and type. Because I need to know the name to be able to compute the mangled name here. But I need this name to be able to look up the definition in the definition cache. And I need to know. Now, I guess I could have the full name and use unmangled to look the definition cache. So yeah, I'm going to store the type. That's what I need. Okay. Do I still need a function cache? I don't think I do. I think the definition cache will be enough. I suppose I'll need to store the new definitions. Yeah. I could do something that stores both, but I think having the name that's already mangled and the type information, which is what I need for the substitution, is probably the best solution. I probably don't need a function cache anymore. I don't need the module definitions because I'm not going to be adding new definitions. Now, the symbol cache, however, I do need because I will be adding all of the functions I am checking as I'm going through them. And the symbol is I don't have it somewhere. Huh. Oh, it's just a function. Okay, it's just the function stuff, which will in fact become, and I can probably already change it, inject. Do I have function somewhere? Function info, function type. I'll probably want to add a missing function. Yeah, okay. I am missing function. Right, this is gonna be, as we said, oh no, because it's gonna be something different. I need to think about this. I will also need a function, which is the output, which is the raw thing, which is the symbol. And the function contains function type, I suppose. That's important to have. I will need that. Function type. And it will contain a function body, which is a bunch of statements with location still. We have not moved from that. Okay. Oh, that's a block. Perfect. I have the alias. And we're gonna call that function info for consistency with previous things. So the symbol at the output will be this type will change, but I will indeed need a symbol cache, which is gonna be what we actually compile, which is the functions. So this is where we're gonna be adding the functions that we actually finish fully analyzing. The instances I need, but functions and fun types, however, I don't. So I will need something different. So I have access to the definition, but I will want to keep a cache of types. So I will want to keep a module. This is VS, and this is gonna be. I'm gonna keep a type cache, which for now I'm gonna type, and we'll see what it becomes. Which becomes for a name a type chain actually. Which is this thing, which then allows me to find the type by doing substitutions on the thing. Wait. So the point is this will always be concrete, but this might not be. This might contain mapping. This should not. It could still. Like, could a struct type still contain something that's not? No, the goal is that it never. This type is never abstract. It never contains a type parameter or anything like this. But the type alias might. So type alias is a layer of indirection. Unless I don't bother with the type chain at all. Maybe I don't bother with the type chain at all. I remove that. I give up on it. And instead, every time I need to look for a type, I look in the cache. If it's not in the cache, then I look for its unmangled version. I look for its unmangled version in the definition cache, and I proceed from there. And that means every time I do that, I might reprocess a few things, but since types have already been resolved, that's purely doing the lookups anyway. So I think that's what I do. I keep a cache of the concrete types, and the non-concrete types will have to be resolved through lookups of the definition cache. Okay. And the last thing we're gonna need is going to be the value cache, I suppose. Oops. also going to be a hash map from name, but here this will be pointing to values in the scope, and values in the scope will be of two kind, constant and functions, basically. And I guess a value cache is therefore just an expression. Which will be either at the top level, some kind of constant. And constants will always be trivially expressed as one of those. Or it is a function name expression that points to a name. And I suppose it needs to be a typed expression. Do I want the function type? Do I want the function type in a function name expression? Probably. Probably. Even though I might not need it. Because the type will be associated with, like, this is a typed expression always. Nah, I probably want it nonetheless. It's probably always good to have it for redundancy, since I already have it for call expressions. Okay. And this is therefore a typed expression. Okay. Okay, and now for the context. That is, when I am analyzing a function, what do I need to keep in scope that is specific to that function, but that I will need to stack because analyzing a function might make me analyze another one. Hello, I've been using Haskell for a bit over a decade by now. I joined the Haskell meetup in Paris back in 2014, 13. And then I've been using it both professionally and personally since then. So the thing is, I don't need the scope anymore. The scoping thing is purely for checking where names belong, but we've already yeah, Haskell is my favorite language. It's not the only one I know, but with time, it's the one I've ended up being the most comfortable with. It's a thing I've used to teach it in the past as well. It's a thing of like learning Haskell when you've only learned more imperative languages in the past forces you to rethink how you think about programming because it is such a different language. And I found that the guarantees and the way of thinking about Haskell, like way of thinking about programming, has changed radically the way I think about programming at large. And it I don't think there's like a like for anything programming, it's very rare that there's something that's strictly better than someone else. That's something else. It's really a matter of context. I would say that there's often it is functional programming is more often suitable to represent things. You run into limitations of object-oriented programming a bit faster in my experience, but that doesn't mean that there are not things that are for which object-oriented programming is not the right approach. There was a big boom towards object-oriented programming like a decade, 2 decades ago, and people are like coming back from it a tiny bit. But it is one of the paradigm shifts of Haskell, recursion everywhere. But the biggest for me was the complete lack of mutability. You never mutate anything. You don't have a struct and mutate its field. You create a new struct with the modifications. You never mutate anything in place. Except for the rare cases where you do, but it's very, very rare. And when you do, the type system will fight you to make it very, very hard for you to do so. You do not mutate things in place. Everything is transformation. Very few things are actual mutation. I've never tried Elixir. I've heard about it, but I've never tried. I've tried OCaml 20 years ago, but that was a while back. I've forgotten a lot about it. You're never mutating anything. The thing is, Haskell is a compiled language. And it used to compile to C for a long time, so it will generate code that performs mutation for efficiency. But purely at the Haskell level, you do not mutate stuff. But again, and once again, the compiler will generate optimized code and therefore will generate mutations for you underneath because, you don't have infinite RAM to work with. I do want the location, I think. I think that's useful. And I do think I want the fun type. It's a thing, like you express everything at the Haskell level with immutability, which makes so many things different, but gives you so many guarantees. And then the compiler has a lot of information about exactly what you're doing because the language is extremely rich and generates extremely efficient code that doesn't have to be immutable because that guarantee is only important at the language level, not at the generated machine code level. And again, the compiler can do a lot of optimizations because it knows that a lot of things are pure because mutations can't happen in them. Well, you can do randomness, but basically there is a corner of the language which is the IO stuff. IO is basically side effects can happen, and you can drag actual randomness from the system. You can drag talking to the file system and the rest of the world through IO, but IO has a lot of constraints, meaning if you're doing side effects, if you're doing randomness, if you're doing things like this, the type system will reflect that. And as a result, if you're not doing side effects and things like this, the type system will also reflect the fact that you're not. And if you're not, then yes, functions are purely deterministic and pure, and therefore you can like do a lot of optimizations on them. The things I think the parameters are something we will not need to keep. Wait, no, we need to keep that. They are gonna be what we use here, basically. As in, okay, in this context, this type parameter is this thing. So no, I think we need to keep that, and it's gonna be type here. Okay. And I think I'm gonna no, I'm not gonna keep the within loop. I think there's a bunch. I was tempted to keep as much error handling in the analysis phase as much as possible, but it turns out that since I do the control flow analysis in the IR lowering phase, that's where doing a lot of the stuff uh, like control flow analysis, wrong errors on like wrong returns and stuff is done. Therefore, I think checking for loop here makes no sense. Therefore, I'm gonna make the context just that. Okay. Okay, so I will move a few more things from the old monad pre-refactor. I think this current context, current scope, current everything is pretty good. Although there's some of them I don't need to keep. Scope no longer exists, for instance. That's not something I need to keep in scope. So location, fun type parameters. Yeah, that's basically all I need. Okay. I think with context, since the scope is no longer a problem, I don't think I need to worry about this scope thing. So I think I can just do a with context. which will take no scope, no name, no nothing. Actually, no, I didn't. I do need the name. Name and location, and that's about it. Yep, that's gonna be about it for now. And I will probably... Oops, sorry, the chat has continued quite a lot, sorry. Um, well, it's less of a class, it's more of a record, right? It's like it has a bunch of fields, but that remains, so it's not a class in the object-oriented sense, it's more of a struct in the C sense, if that makes sense, which is weird to make a comparison with C, but yeah. God, the point about like, yeah, the pain point is no jobs. Haskell jobs are few and far between. I was very lucky to have one for like 3 years from 2020 onwards. But yeah, Haskell jobs are very few and far between, especially if you don't want to work in crypto. Oh, sorry. Yes, data structures. Yeah, they're basically kind of like, well, this is kind of like a C struct. C struct. Although here you're talking at a much more abstract level. This is actually a pointer under the hood and so on. This does not, you don't have a guarantee that the compiler will use this specific layout in memory. This looks like a struct, but the compiler is very free to interpret this as it wants, because again, we are such at a high level that the compiler will do whatever it wants with that information. But you can think of them kind of as C structs. But this is immutable, yeah. So if I want to create a new validate context, but with a different name, I'm basically creating a new one. Like for instance, if I do a replace name function that takes a validate, like a name, I can't type, I'm sorry, a validate context, and it returns a new validate context, which is the new modified validate context, I would have to use something like new name, old context. I will be returning the old context modified so that the name, the context name is the new name. And that's a new value as far as the thing is concerned. That function takes the old one, returns the new one. So I'm never mutating this one in place. Of course, I'm using constructs in the language that allow me to simulate mutation in some places, but you know, at the core of it, and that's the thing I find beautiful about Haskell, is that there's very few things in the language that are not defined in terms of the language. There is no mutation at the core. Okay, so with the context, I need to just... I will probably just return an A because I've changed the way my diagnostic report works. No top level scope. No within loop. And ensure result. There we go. So with context is all I'm gonna need here. So that should be all I need. That means that when I am doing my validation, unless I want to keep a cache of type stuff, of type information, of type graph or something, which I probably don't want to. I might actually want to keep something like that. So the point that I want to arrive at is, again, I want to be able to have type, which is this cyclic graph here, where for each struct, I know that if a type for a struct of something is like a struct, it has a non-empty list of type, which are themselves like types like this, which could potentially be creating cycles, because a struct A could have fields, a field which is a list of B, and B could have a field which is a list of A. And that's a cycle in the type graph, and that's fine. However, I want to have a cache of for a given unique name. I want to be able to know what type is associated with it, but this type is a concrete type. Um, there is no type parameter information at this point. This is a point where all of the type parameters have been substituted. That means that I think that's fine. I think that's fine. It just means, yeah, it just means I can't cache anything. Well, you don't. Well, you use recursion, right? You use you call the next step of your function with the updated counter. But that question of like how do you do a counter is the reason like I became enamored with that language when I discovered it like again more than a decade ago, because I arrived at that point with already like a decade of well, not almost a decade of software experience, and it's like I don't even know how to get started with this. I don't know how to do anything with this. But you can do anything with it. You just have to rethink how you think about computation. People make video games in Haskell. People make like window managers in Haskell, like or servers or anything you want. But it is a different way of thinking, and that's the well, as long as your recursion, I've had a few cases of Stack Overflow, but the compiler can, again, this is a very high level language. The compiler will do optimizations. Tail call optimization is typically a thing where the compiler will translate your recursion into loops if it's possible in the current context. So there's going to be a lot of places where the compiler like avoids that for you by just optimizing for you. So you write things in recursion and immutability at the Haskell level, which gives a ton of information to the compiler to know exactly what you're trying to do, and the compiler can generate code that does what you have described, but optimized and performant. Like at the Haskell level, everything is immutable, and then the compiler generates, like it's used again to generate C code before, and now it doesn't do that anymore. But for a long time in the history of Haskell, it would just generate C code that correspond to what you've expressed in Haskell. And in C, of course, everything was mutable. And now it just directly generates machine code, but you know it still does the same thing of like it translates what you have meant at the very high level abstract immutable thing into something practical, concrete, and performant. Okay, so now I need to think about I need to think about, do I keep, I think I just don't, which means the checking process as a result, the validation process, will be purely about validating the functions, I guess. I guess I will have to do. I can do something like this that validates whatever top level declaration I found, and it's just that for types there's nothing to do. There's nothing to do unless they don't have type arguments. I suppose. Yeah, I think that's it. Okay. Which means basically for everything that's generic, even types, I delay until I'm able to resolve. Yeah, I suppose that works. I guess that makes sense. So, okay, I encounter a top level definition with its location and a given name. What do? I think this was more or less what I had here. I might not need to do the cycle detection here, actually. I might not need to do the cycle detection here, because the cycle detection will only be required when doing type resolution, which will not happen here. So I think I might be able to even go one step further and remove this stack here. Sorry, I missed your message. Yeah, no, C minus minus, I think no longer exists, to my knowledge. For a long time it existed, but I think, well, I mean, C minus minus as a backend for Haskell no longer exists, to my knowledge. I think you can still like force GHC to generate it, but it's not the normal pipeline anymore, if I remember correctly. Okay, so if I don't need that anymore, I can remove that. I don't have the context definitions anymore. Which is fine because I don't need, because type errors. Okay, the problem of this idea of I'm not caching information about types before I fully resolve them into concrete types is that if a struct contains something that is wrong, I will have one error message per time it is wrong if it has type parameters, basically, which is kind of annoying in terms of error reporting. That's not the end of the world, though. So maybe I can just do that. Or rather, I can maybe do something smarter. I can keep a set of scene validated, which is just going to be a set of name. Why am I not using... Why was I using a different set than the hash set? Probably because I had something that could not be hashed, I suppose. I can do that. That at least avoids... Yeah, I think that avoids having to... It will allow me to duplicate error messages, I think. However, the problem... So, okay, so that means if I encounter something that I had to look up... It's not in a cache, so I have to analyze its definition, and I see that it was already analyzed, I guess I can conclude that it ended up in an error. I guess it depends on the kind of thing I'm doing. I guess I can reuse the same thing I was using before, and I can put a maybe here and a maybe here, where maybe indicates I have already tried to do that and it failed, therefore the current thing you're trying to do is also going to fail. Except now, since I have two caches, it's going to be two different things, but I think that's probably the best approach for this, which means that this is not at this level that I do that. So here, there's no longer any cache checking at this point. So this becomes purely a case on the definition. If it's a type alias, I do nothing. There's nothing for me to do at that point. If it's a struct definition, there's nothing for me to do at that point. If it's an enum definition, there's nothing for me to do at that point. Those will be checked. Those will be checked afterwards. If it is, however, a constant or a function, this is where I have some validation to do. This is where, okay, there's a issue with, okay, no, I'm gonna go back to my previous idea. Rather than having a maybe here, I'll do that. Because then this can be the unmangled name to avoid having to, because that cache is a mangled cache. I mean, sorry, I haven't followed the entire conversation, but I will point out that like learning more different ways of programming will always make you better at languages that even don't use that thing. You will become a better C++ dev by knowing Haskell. You will probably become a better Haskell dev if you also learn C++. Like having more understandings of different forms of programming will make you better no matter what language you end up using. That's something I strongly believe. And I mean this. I think learning brainfuck makes you a better dev because learning brainfuck makes you really think about some of the low-level assembly stuff almost. Like I think there's value in learning any new way of thinking about programming, and any new kind of language that has a new approach to something, I think is valuable. So here, type alias, we have nothing to do, I guess, for this at least. And here we do nothing. And constant and functions are where some of most of the work will have to go. So this is going to be analyzing a constant. And this we will be analyzing a function. That's going to be it, because that's the only thing we need to do. We only need to export something at the end. So we just need to write this in our symbol cache. Where is that? Here in our symbol cache, which is going to be yet one more hash map from name to something, which I think for now I can write as hash map from name to function. Excuse me. Okay. Okay. Except those are now named validate, since this evening we have split the old code of the validation of the analysis into two functions. So validate const is going to be a function that, given some underlying monad m that we will go back to, and we need to do the with context here. With context takes name and location of the definition. So I don't need to give the name here, it's already in the context. I will need to take as an argument a const info resolved, which I will probably need to distinguish between Haskell docs are pretty good. To install nowadays, the recommended thing I think would be GHC up probably, because it gives you like a list of all the tools and compiler versions and everything, and you can maintain which one you want to install. whether you want to use stack or not is up to you, but like GHCup is the way to make sure that you have the things installed on your system. And the documentation of Haskell, the only downside is that it requires being used to read Haskell types. So at first, as a complete beginner, it might not be the most convenient, but it has the upside of it's always standardized the same way, kind of like the Rust doc, and tends to be pretty good. It has jumping to definitions from different things. Will like jump to other modules across libraries. You can always go have a look at the source of the thing if you want, with syntax highlighting and jumping to definitions within the source display and everything. No, the Haskell docs are pretty good. This is going to return an analyze m. And does this return anything? I don't think it does. I think this analysis thing just perform a change. Unless I do the updating in here, possibly. But I don't think I will. I think it makes more sense to have each of the top level decide what it wants to do. So I have a const info here. So here is where I'm gonna try to oh, do I want to try at this point? I probably want to try. Yeah, I probably want to try. And then I will need to void. But to recover from an error happening here. And then as a result, that thing will... Ah, no, okay. I'll do the updating here. So here I will get the result of something, which is the result of like, oh no, no, actually. Ah, this is tricky. So the result is getting a try of the validate of the thing. And I suppose I will only... And I can update the scene thing with this always, regardless of whether it failed. Okay, so how is it called? It's called validated. Validated will be modified to insert the fact that that name has been validated, regardless of whether this one succeeded or not, basically. So I don't even need, I could just avoid it, yeah. And same here, I void the thing and then I insert the validated in it. Okay. Unless I make those things return the result and I make updating the symbol part of this. I think I prefer that. So let's do that instead. So here, if I find a constant definition thing, but if I analyze a function, what does it give me? It gives me the symbol. Not necessarily. It depends on whether it's a generic function or not, is the thing. So, yeah, I can't. That means the value cache, the name of the function. Yeah, the fact that my language is poorly defined in terms of language pointers doesn't help. So I don't think I really need to put... I don't think I put the function names there. I think places where I have a function expression will just resolve them based on the context, which might be with types, and therefore we'll put that in the cache. Okay, so that's not going to be done there. So that means the output of the checking of a function will have to be... Nah, it's going to depend. Okay, so I'm not going to do any of... Oops. I'm not going to do anything at this level. I am going to let each function decide what is the result of doing the analysis. For constants, since there's no type arguments, there's no genericity there, they will just be inserted in the cache. So, validating a constant will be obtaining the type. So this will be validate a type, which might fail, but if it succeeds, gives me the constant type based on the const type. I'm going to call it the checked type or validated type, which is basically going to do the same thing of like, we've already done name resolving. This is purely going to be about doing all of the loops, obtaining the type information that can be cached. And then, of course, validated expression will be the result of validate const expression. And I think I will keep the thing I had before, even at the risk of duplication, where I will have a separate function for constants. So I can have clear error messages of like, oh, some of this doesn't belong in a constant. I think that's the easiest way to go about this. The result of which can therefore be put in a if both of those things have succeeded, then I can using the name that I know from the context. So const name is the current name. I can modify the value cache to insert for this const name a typed expression, which is the validated type and the validated expression. Is there anything else we used to do before that we no longer do when it comes to a constant? Aha, there is more. We need to also check that the type of the expression matches the Oh, there's a thing I was just thinking here in common in checked. I will probably want actually it's fine to have a name there. It's fine to have a name there. It's fine to have the indirection because I might want to preserve it when it's fine to preserve it since I might want to introduce that kind of indirect of type breaking anyway when generating the LLVM IR at some point. So I think actually I can keep this, and resolving the cycle will be done. I can resolve the cycle at a later stage when I generate the type information in the IR, and I will already have guaranteed that there's no cycles. Okay, okay, I'm gonna keep names there. This is tricky. So here I do need to check one more thing. Since type is always going to be concrete, then I should be able to use normal comparison for type checking. I no longer need type matches because I no longer need to do partial type checking with placeholders and things like that. I am comparing the actual type thing, and those are only the same. Ah, that's not true. I need to also be careful. I need to be careful, and I need to probably keep the name of the enum there, so that the equal comparison actually does compare them. Same for the struct. I probably need to keep the struct. Or can I just check the name, actually? Can I just check the name? Well, no. I can't check the name because while a name uniquely identifies a type, more than one, like an actual concrete type, the name I have could be pointing to a type alias that is then resolved into something else. So I will need to carry name and name, I think, for the purpose of this. For the purpose of this, yeah. Okay. And so I can make an instance EQ for this, which is basically, are those types the same? And this is going to be a equals b is a function that is defined as case a b of, if they're both int types, the answer is true. I'm just gonna get that. Okay. What bothers me a tiny bit with this new approach is I am reusing the thing name for two different things, for the unmangled thing and for the true canonical version, and that could very quickly lead to some confusion. To the point where I'm almost tempted to change, but that's gonna break even more things. That's the mangled name that contains the parameters. Do I want to have core name or something. Core name is that. I probably don't, but I'll have to think about it. I will have to think about it to make sure that I know. For instance, in this cache, is the name the mangled version or the non-mangled version? And I think having a type distinction there would be very good. Because otherwise I risk doing lookups that fail because I'm looking for the mangled version and in fact there isn't one. No, I think I need that. I think I need to clarify this. How do I change that? A base name. It's going to be something that contains a module name. And an identifier. And the name is gonna be something that contains a base, which is gonna be the base name. And the parameters, which are also gonna be names. That's the mangled version that contains all of the information. So now unmangle is no longer that, and it might no longer be required. And now I can change everything again. This cache is a cache of name. This cache is a cache of name. This definition cache is a hash map from base name to a definition resolved. This is value symbols, type cache, value cache, all of those are name. Instances is a base name. There we go. Validated is a base name. And in the context, I have the base name. Yep, okay. That means that the output of my previous phase, the resolving phase, the resolution phase, is... the name is not there. Okay, perfect. But all of those will be base names, basically. I have few names in this, which makes it easier. Okay. I probably have some in the monad. That's going to be the base name. Well, thank you for tuning in. And as a result, this is going to be a base name. Oh, I need to go back to past as well, because now this is going to be... I can probably move path as part of name, come to think of it. Path, a module name, a base name, that's just... Okay, so the output of this phase that we haven't done yet will be the thing with the base name. Let's see if there's a lot of names in there. There isn't. Okay. There's probably no need to have this source anymore because I don't think I need the AST anymore for this because role is no longer in there. Okay. So resolution here no longer has a lot of names. That's good. Diagnostic. Oh, diagnostic. I haven't touched diagnostic at all. Diagnostic will probably be mostly base name. That's a lot of path info resolved. Probably things we're going to want to change at some point. Yeah, diagnostic is something I'm going to have to redo anyway. Okay. I am changing absolutely everything. This is fine. All of that to say, if I go back to checked here, I can go back to this. An enum type, therefore, I will compare the names, not the values. And it will be true if n1 equals n2. They must be pointing to this exact same name underneath. A struct type with n1 and field info must be up, there we go, is n1 equals n2, which means even if two types have the exact same fields, I will reject it at type checking. However, function type is purely any function is compatible with any function that is, so it's just a direct comparison. That's f1, f2. There we go. And everything else is false. Okay. So that means I can go back to validation. And here, the validated type must be equal to the typed, how is it called again? Typed, I haven't named them. I probably want to name them. I probably want to be able to extract that out of something. Typed info, type value. Okay. So that would be type info of the resolved expression. Unless those are equal. So basically, you declare your constant as an int and then your expression is a string. That is wrong. So that's a wrong type. Validated type. And expression type here, so that's the type info. Otherwise, add it to the value cache. I guess functions can also be added to the value cache that way with the actual mangled name, I suppose. It probably makes no sense to do so. Okay. Now, that's constant. Well, except const expression and type haven't been done, but that's the top level thing. And validator function will be somewhat similar, I suppose. Except I only want to validate functions that are not generic. If it's a generic function, I cannot validate it. So I guess the only thing I really need the validation cache set here is for constants, right? Ah, no, I probably want the actual name. Yeah, I probably want the actual name, I suppose. Yes, I think so. Of course, so I will need to make a name for... Okay, so the const name will be the current name, but that gives me only the base name. Let const name be a name with the base name and no parameters. There we go. I think as a result, I'm just gonna put the validation in there. As the first thing always, basically. Come on. Wait, I need to check that then. That makes no sense otherwise. So I need to do that. And here, unless M of uses validated to do a lookup of the const name, do that. Okay. Validate function, I suppose then, will be somewhat similar. So here this becomes I will need to make a difference between validating a function and instantiating a function. It's gonna be annoying. It's gonna be very annoying. I suppose here what I do instead is when not is generic the function, then validate the function. And here, if it's not generic, I can give it type parameters, and the type parameters will be a hash map from identifier to type. So what types it is instantiated with. Oh, I'm in the wrong thing. This is the type of validate function. it contains a function info resolve here instead. Then a hash map from identifier to type, which are the type information for that function. I guess this is not an empty list, then it's MMT. And returns nothing at the end. I probably actually need, if I do a hash map like this, the problem is I have no guarantee on the order of the types. So it should not be a hash map like this here as an argument. It should be a list of types. Which means I can go back here and fix that to be indeed an empty list. So first I'll have to do, so definition, that's a function info. And type parameters. So what I'll need to do here is a few more things. I'll need to do the fun name, which is going to be the base name, and the list of type parameters. Unless it is already in the cache of things that are validated. Put it in the thing, and then do the rest, draw the rest of the owl. And at the end, we will add it to the symbols that are exported. I suppose I could add it to the value cache. Although I'm not sure there's really a point in doing so. I guess it avoids having to look at the declaration, I suppose. So yes, I suppose value cache will be modified to insert the function name, and the typed expression will be a function name expression with the same func name and a function type which will also be part of this being a typed, so it's going to be very redundant, but it's better than not being present. Typed will contain the resolved type as well. Which is going to be that function type here. Okay, and the function name expression will contain it as well in here. Okay. Well, not resolved type, but I say fuck type. unimplemented for now. And at the end, we insert it into the symbols, we insert it into the cache. Okay, now, what did we used to do to check functions beyond just checking okay, analyze function, analyze block, perfect. So it was very straightforward. I knew that was going to be the case, but we're not going to finish this evening. And it means after 8 hours almost of work, we're not going to be anywhere near being able to compile after this big refactoring. That's a bit stressful, but hopefully, if I do another big stream this week, we might be able to make some progress. So, it's going to be somewhat similar, except the function is different. Usually it's twice a week, every Tuesday and Thursday, usually starting around, well, I'll say 8 p.m. UTC. Dublin is not always on UTC, so 8 p.m. Dublin time usually. Today I started a lot earlier because I wanted to try to do a lot more. Some weeks I do a third stream on Wednesdays if I have the time and spoons. It was the case last week, but it might not be the case this week. I'm looking for function info, which is just type and body. Okay, so that's basically almost exactly that. I'm just gonna go here, copy that, because this is in short gonna be what we're gonna want to do. Func type is gonna be the result of doing validate function type. Body is going to be the result of doing validate block. Where I will not need to care about the scope anymore. And the result will be a function info with just the func type and the func body. Oops, which is going to be named func info, I suppose. Okay, and then it's added to the symbols, and that's the closest we have to, like, that's the thing we're going to be translating into the IR afterwards. Okay. Now, I think there are two options at this point. I could start doing the constant expression and the function body, which are gonna be mostly about copy pasting the things I had before, or I can try the cyclic type stuff, which I think is gonna be a lot more complicated. So maybe I should start with it, and the reward for when it actually works will be to just have to copy paste stuff. So I am going to want to do a validate type. Validate type is going to be a doozy. So I have some type, which is the result of the previous phase. Being the result of the previous phase, it will be represented as a path info resolved. I want this to give me a type. Now, I have the source path, and I can immediately do a case on the... Actually, I'm just gonna deconstruct it like this. I can do a case of the path name. And that is gonna be, after the output of the previous phase, a thing called a roll, which is in common? No, it is in resolved. It is that thing. So if I'm trying to find a type, this is the things I have to have a look at. So if it is a built-in type of a given unique name, that's pretty convenient. I'll just need to be able to find... Maybe I don't need a name for the built-in type then. Maybe I can... Maybe I can translate the role into something else rather than having built-in type and having something there. Or I could just do a... Yeah, I can just like... Okay, if that's a name, if it's an int name... Because built-in is what I'm looking for. I might probably want to change a few things about this. Yeah, I probably want to avoid that. Okay, let's think about this. Downside is basically here I have to do something partial of like, oh, I know this is a built-in type that tells me nothing more, and I have to check this to convert it back into one of the other types. I think it's fine to just do it like this. That is a that is gonna be a int type. And I need to handle the basic one. 1, 2, 3, 4, 5. Aha, but those cannot... Those are not valid types, are they? I guess they are. I guess they are as far as this is concerned. Is it? I guess unit is represented by a lack of type, so no, it's not. It would make no sense for something to have a built-in type, unit type for... Because unit is usually represented as the lack of a type. That being said, no, I will have a few things that have a type unit. So I think I need to have unit type and void type here. Those are things that makes no sense for the code generation phase later on, but for the type checking phase, they do make sense, which means I need to handle them at this stage as well. Unit type is equal to unit type, void type is equal. Wait, haha. And that's why I don't want to use EQ. Remove this immediately. Because by definition, void type checks with everything. That's the whole point of void. So let's remove this and type matches to reuse the function I had before with type boolean will be if one of them is void, the answer is true. Always. Because void is always type matches, that's the whole point. So it's possible to do error or panic on anything, and the value of that will be void, which will always be accepted as a valid value for whatever. So const x is an int equals unimplemented is valid. That's the whole point. So pure unit name, that's going to be unit type. And void name is void type. Okay. A built-in function, regardless, is going to be an error, unimplemented. I guess this is going to be a fatal, not a type, error, not a type. Which I think takes the path name. Struct enum are gonna be so enum name. I'm gonna need to have a look at the declaration, but it should be fine. So that's gonna be validate struct with validate struct, and I will want to probably give it something else. I will want to give it the full path info, I guess. Or no, probably not. Oh, this is going to be a base name, isn't it? Role. Let's go back to role. This is going to be in resolved. All of those are going to be base name. Maybe built-in function won't be. I'll have to think about this. It's going to be base name, base name, base name, base name, base name. Yep, all of these are going to be base name. Hence the importance of remembering the distinction between name and base name, I think. So validate struct, this will have the base name here. And here I'll be giving the base name. So what was it declared at, but the name doesn't contain all the type information. And I am trying to resolve a concrete type. Therefore, I need to have a look at the type parameters, which are, actually, I need to resolve them first. So first, I need to I'm going to have to make sure that I detect the cycles properly. This is going to be a nightmare, however, otherwise. Okay, so I will want to first resolve all of the other names. So that's a path info that contains the path name and the path params. So I will want to going to be a traverse validate type of the path params. Then that will be a list of type from which I can construct the actual name. So that's going to be the resulting type. That is not a type, so it's easy. Constant is not a type, that's easy. To the point that I might just want to just use a blanket one for everything else. At the risk of whenever I modify this role thing, I'll have to make sure I have covered all of my bases. Type alias. So if we encounter a type parameter that is convenient, that means that we could just do a lookup in the current context. Not context. It's currently in another thing that I want to look. Yeah, that is that. And if it's not there, then I know for sure that the type is missing. So that's fine. Now the question is, what do I do if I find a placeholder? What do I do if I find a placeholder? How do I handle placeholders? With this new approach, any name could be a placeholder, but there are places in which it's fine. There are a few places where I will allow it. The few places where I will allow it when I'm resolving a type will be the let binding the type of a let, the type of a struct. And what does that mean? It means I can get something where the type gives me. Oh wait, no, no. The placeholder isn't there. What does that mean? It means I can't get a type that's unique. I get something that's incomplete. Does it mean that I can introduce? Can I introduce placeholder there? And then I need, I suppose, to distinguish between whether this is a valid type or not, basically. Aha. Okay, for placeholders, this breaks everything. As a result, I'm tempted, since I've been at this for at this point close to 8 hours, I'm tempted to take a break for this evening and think about how I want to change placeholders for the purpose of this. Because they are good, I want to keep them. It's nice to not have to put the types everywhere. However, it means I cannot just like, oh, this must be a type, therefore I must be able to fully resolve it. There are places where I will have to accept that things can be just a placeholder. And that's that just probably means I will have it to have a different way of resolving this. I think that means I'll have to. Yeah, no, okay. This is too complicated to solve on the fly. I'll think about it, what it means for struct expressions, what it means for function calls, and we will see that next time. Thank you for tuning in. I hope you had fun. Sorry for the like absolutely horrible state of the code after breaking everything, and we will continue breaking everything next time. Have a good night, everyone. Thank you again.